Hi everybody. So we made this chart in the earlier video, and I just want to finish this assignment by showing you how to create a new chart sheet and to make additional charts very quickly without having to start from square one. Now we made this nicely formatted sheet here. I notice now that this is 14 point and this is 16, so I'm going to make them look the same and make that 14 point. I'm going to double click where it says sheet here and just call this mono craters crater data. And that'll differentiate it from new sheets. So what I want to do is I don't want to have a cluttered desktop. So if we back out, we've got a lot of data here, and we're going to make a lot of charts. And I want you to be able to make them quickly without wasting a lot of time. And so I think this is the easiest way to do it. What we're going to do is we're going to insert a sheet, but not just any kind of sheet. We're going to insert a chart sheet. Now I've still got the cursor down here, so I need to get out of there. Otherwise it won't let me do it. All right, so insert sheet, and we'll choose chart sheet. And there it is. Now it makes something crazy because Excel just decides on its own what it thinks we want, and so I'm just going to delete all this stuff. It's not always obvious to me how Excel decides what it wants to plot, but I just erase everything until I have a blank sheet. Then I come back to this chart that I made here. I'll select it, so notice that we get the box outline, and I'll write copy, and then go over to this sheet that we just made, the new chart sheet, and hit paste. And there it is. So that's the chart. I've plotted calcium versus MgO, so I'll call this MgO versus calcium. And now I don't really need this sheet anymore. I would ordinarily delete it, but I'm going to use it for other examples, so I'm going to shove it off to the side. But what I want to do now is I want to plot MgO versus other stuff. Now we use MgO on this horizontal axis because it's a good index of differentiation. Magma evolution occurs starting at high MgO for the most primitive and moving towards the lower MgO for evolved. And let's see if I can insert a text box, and will it let me? Yeah, it will. So over here are the primitive lavas, and then over here are the evolved lavas. So we can draw an arrow that takes us from the most primitive to the most evolved. So these are the liquids we started out with, and through Bowen's reaction series, which we'll look at later, we can have crystals fractionating out that will eventually get us down to here, stuff that is much lower in MgO, and also, we can't see it here, but also higher in silica content. So what I want you to do for this assignment is make charts where we plot MgO against all the other oxides. So I showed calcium, but how about silica? How is silica varying? Well, what we're going to do is go to Edit. No, excuse me. We're going to go to Edit, Sheet, Move or Copy Sheet, and we're going to click this box, Create a Copy. And then when we say OK, we've got this new sheet, MgO versus calcium 2. But what I want to do is I want to change it, so I'm plotting, instead of calcium, I'm plotting silica. So I've changed the title of the sheet. I'm going to change the axis. And then I'll come over to the data. So let's click on this for a moment. Up here, it tells us that we're plotting column G against column H. If we come back to the data, G is MgO. We'll keep that. H is calcium. But instead of H, what I want is column B. So we see silica. So I'll click back on the chart and change the H to a B. And so now I have silica. The primitive lavas are still over here. And here are the evolved lavas. You don't really have to draw this line. This is really just to show you what's going on. So we have primitive lavas that have high MgO, and you can see that they're increasing in silica content. They start out around 50 weight percent, so they look a lot like the mid-ocean ridge basalts we saw in another lecture, and then they're moving up to things that look more like rhyolites. Now, there's one other thing that I want you to do in making your charts. There's a lot of empty space here that we don't need. There are no lavas with less than 50% silica. So I'm going to double click on the silicon axis, and I'm going to make a minimum value that is, I think 50 will work. So the minimum will be 50. And that allows us to see much more of the variation. And again, this is really just for teaching purposes. You don't have to have these labels. But since I've made them, I'm going to move them down. Here are the primitive lavas, moving towards the evolved lavas. Now, there's some empty space up here too at 85. I think I'll make the maximum be at 80. So now we could see a little bit more of that variation. The MgO variation seems to be fine. I think going from 0 to 5 is okay. I'm gonna get rid of this now so it's not interfering with our look at the data. Close this. So there we go. We've got MgO versus SiO2. And what I want you to do for this assignment by next Monday is plot all the other oxides against MgO. So that means you're going to plot titanium, aluminum, iron. You could skip manganese, but do sodium, potassium, and phosphorus. And you could skip chrome. So just right here is a note. Skip chrome and manganese. But the other oxides, so-called major oxides, go ahead and make plots as separate sheets. And then what you'll send to me is a single spreadsheet like this with a series of tabs that show all of your plots. And I'll be able to click through and see what you've made. And again, you don't have to add the arrow. I just want to see the plots. And then next week, we'll do some modeling of the data. We'll see you then.